Hello everyone, this is Mamta Mund and today we will learn and solve try these questions page number 34 of exercise 2.1 chapter 2 chapter name is whole numbers and of class 6 of NCERT mathematics textbook. Let's get started and solve some questions. Today we will learn and solve exercise 2.1 try these questions of page number 34 of chapter 2 chapter name is whole numbers and topic is predecessor and successors. Let's solve some questions. Now the question number 1. Write the predecessor and successor of first bit 19. We know predecessor is the before number or the previous number. We have to subtract 1 from the number. We can get the predecessor of that number. And successor is the next number or the following number. When we add 1 with the number, then we get the successor of that number. So predecessor of 19 is we have to subtract 1 from 19, that is 19 minus 1 is 18, and successor of 19 is we have to add 1 with the number 19. 19 plus 1 is 20. So predecessor of 19 is 18 and successor of 19 is 20. Now question number second bit B 1997. Predecessor of 1997 is we have to subtract 1 from the number 1997. So predecessor of 1997 is 1997 minus 1 is 1996. And 1996 is the predecessor of 1997. And successor of 1997 is we have to add 1 with the number 1997. So successor of 1997 is 1997 plus 1, which is 1998. And 1998 is the successor of the number 1997. Now question number third bit C 12,000. Predecessor of 12,000 is we have to subtract 1 from the number 12,000. So predecessor of 12,000 is 12,000 minus 1, which is 11,999. And 11,999 is the predecessor of 12,000. Now successor of 12,000. Successor of 12,000 is we have to add 1 with the number 12,000. So 12,000 plus 1 is 12,001. And 12,001 is the successor of the number 12,000. Now question number fourth bit D 49. Predecessor of 49 is we have to subtract 1 from the number 49. So predecessor of 49 is 49 minus 1, which is 48. And 48 is the predecessor of 49. And successor of 49 is we have to add 1 with the number 49. So 49 plus 1 is 50. And 50 is the successor of 49. This is predecessor of 49 and this is successor of 49. So predecessor of 49 is 48 and successor of 49 is 50. Now question number fifth bit E 1 lakh. Predecessor of 1 lakh is we have to subtract 1 from the number 1 lakh. So predecessor of 1 lakh is 1 lakh minus 1. And 1 lakh minus 1 is 99,999. And 99,999 is the predecessor of 1 lakh. And successor of 1 lakh is we have to add 1 with the number 1 lakh. 1 lakh plus 1 is 1 lakh plus 1. 1 lakh plus 1 is 1 lakh 1. And 1 lakh 1 is the successor of 1 lakh. Now question number FB. Predecessor of 24 lakh 40,701. And predecessor of 24,40,701 is the, we have to subtract 1 from the number 24,40,701. And predecessor of 24,40,701 is 24,40,701 minus 1, which is 24,40,700. And this is the predecessor of the number 24,40,701. And successor of 24,40,701 is we have to add 1 with the number 24,40,701. So 24,40,701 plus 1 is 24,40,702. And 24,40,702 is the successor of the number 24,40,701. Now question number G bit. 1,199. Predecessor of 1,199 is, we have to subtract 1 from the number 1,199. And predecessor of 1,199 is 1,199 minus 1, which is 1,198. And 1,198 is the predecessor of the number 1,199. And successor of 1,199 is, we have to add 1 with the number 1,199. And 1,199 plus 1 is 1,200. And 1,200 is the successor of the number 1,199. So 1,198 is the predecessor of the number 1,199, and 1,200 is the successor of the number 1,199. Now question number H bit. Write the predecessor and successor of 2,08,090. This is lakh place, 2 is in lakh place, 8 is in thousand place, and 9 is in tens place. So 2,08,090 predecessor, we know predecessor is the before number or the previous number. We have to subtract 1 from this number, we get the predecessor of the number 2,08,090. So we have to subtract 1, subtracting 1 from 2,08,090 is 2,08,089. 90 minus 1 is 89. So this is the previous number or predecessor of the number 2,08,090. Now successor of the number. We know successor is the next number or the following number. We have to add 1 to the number, we get the successor of that number. So adding 1 with 2,08,090, we get 2,08,091. 90 plus 1 is 91. So this is the successor of the number 2,08,090. Now question number 2. Is there any natural number that has no predecessor? Natural number are the counting number which starts with the number 1. 1, 2, 3. These are natural numbers. And predecessor is the before number or the previous number. We have to subtract 1 from the number, we get the predecessor of that number. If we subtract 1 with 1, we get 0. So predecessor of the number 1, that 1 is natural number, and predecessor of the natural number 1 is 1 minus 1, that is 0. And 0 is the whole number. 0 is not a natural number. So the natural number 1 has no predecessor. So the natural number 1 has the predecessor 0, which is not a natural number. 0 is a whole number. So the natural number 1 has no predecessor. Is there any natural number? Yes. The natural number is 1. Natural number 1 has no predecessor. Now question number 3. Is there any natural number which is no successor, and is there a last natural number? Is there any natural number which is no successor? No, there is no natural number. Every natural number has successor. That is, if the natural number no, there is no natural number. Which has no successor. Because every natural number has successor, we have to add 1 to that number, we get the next or the following number, that is the successor of that number. Is there a last natural number? No, there is no last natural number which is the successor of that number. Now the question is, are all natural numbers also whole numbers? Natural numbers are counting numbers which starts with the number 1. These are natural numbers. And whole numbers starts with 0. Are all natural numbers also whole numbers? Yes, natural numbers are whole number because 1, 2, 3 also, these natural numbers 1, 2, 3 also in the whole number 1, 2, 3. So all natural numbers are whole number, yes. All natural numbers are whole number. Now the question is, are all whole numbers also natural numbers? Whole number starts with the number 0. These are whole numbers. And natural number starts with the number 1. Are all whole numbers also natural numbers? Here 0, 1, 2. These are whole numbers, but in natural numbers there is no 0. 0 is not present in natural number. 0 is a whole number, but 0 is not present in natural number. So are all whole numbers also natural numbers? This is false. So no, all whole numbers are not natural numbers. So whole numbers are not natural numbers. Now the question is, which is the smallest whole number? The small whole number starts with the number 0. So 0 is the smallest whole number. Zero is the smallest whole number. Now the question is, which is the greatest whole number? Whole number starts with the number 0. 0, 1, 2, these are the whole numbers. whole number starts with 0. And which is the greatest whole number? There is no greatest whole number. This is infinite. Infinite. There are infinite whole numbers, so there is no greatest whole number. It is undefined. There is no greatest whole number. It is undefined. Now we solve question number 1. Find this addition of whole numbers on number line. This is try these questions. First bit is 4 plus 5. First draw the number line. Middle point is 0. 4 and 5 are positive number. So positive integers on the number lines. Positive numbers represented on to the left hand side. To the right hand side, this is 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10. 4. Starting from 0, move to the right hand side. This is 0 to 4. 4 then plus 5. 1, 2, 3, 4, 5. So this number is 9. So 4 plus 5 is 9. This is the representation of number lines, addition of numbers 4 plus 5 on the number line. Now question number second bit, B, 2 plus 6. First draw the number line, 0, whole numbers starting with number 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 0 to 2, then 6, 1, 2, 3, 4, 5, 6. 2 plus 6 is 8. This is the number 8. So 2 plus 6 is 8. This is the representation of number line, addition of numbers 2 and 6, that is 2 plus 6 on the number line, and we have 2 plus 6 is 8. Now we will solve question number third bit, C, 3 plus 5. First find this addition on the number line. First draw the number line starting with 0, whole number start with 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 0 to 3, this is 3, then 5, 1, 2, 3, 4, 5. 3 plus 5, this is number 8. So 3 plus 5 is 8. So this is the representation of addition of the numbers 3 and 5, that is 3 plus 5 on the number line, and we have 3 plus 5 is 8. Now fourth bit, D, 1 plus 6. Represent the addition of 1 and 6, that is 1 plus 6 on the number line. First draw the number line. Whole number start with 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 0 to 1, this is 1 number 1, then 6, 1, 2, 3, 4, 5, 6. This is the number 7. So 1 plus 6 is 7. And this is the representation of numbers 1 and 6, that is the addition of numbers 1 and 6, that is 1 plus 6 on the number lines, and we have 1 plus 6 is 7. This is 1 plus 6 is equal to 7, which is represented on the number line. 1 plus 6 is 7. Now the question is, find the subtraction of whole numbers on the number line. First bit is 8 minus 3. First draw the number line. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 minus 3. First move, starting from 0, move to the number 8. Now it is 8. 8 minus 3. From 8 to 7, 1 unit. So we have to subtract 3 unit. So 8 to 7, 1 unit. Then 7 to 6, another 1 unit, that is 2 unit. And 6 to 5, another 1 unit, that is 3 unit. So 8 minus 3, it is 5. The number is 5. So 8 minus 3 is 5. And this is the representation of subtraction of whole numbers 8 minus 3, which is 5, on the number line. Now question number second bit B, 6 minus 2. Represent the subtraction of whole number 6 minus 2 on the number line. First draw the number line starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 6. Starting from 0, move 6 unit, that is 0 to 6. 6 minus 2. From 6 to 5, 1 unit, and 5 to 4 is another 1 unit. So we have to subtract 2 unit. 6 minus 2. So 5 to 6, 6 to 5, 1 unit, and 5 to 4, another 1 unit, that is 2 unit. So 6 minus 2 is, now the number is 4. So 6 minus 2 is 4. And this is the representation of subtraction of whole number, that is 6 minus 2, which is 4, on the number line. So 6 minus 2 is 4. Now third bit C, 9 minus 6. Represent the subtraction of whole number 9 minus 6 on the number line. First draw the number line. Whole number starts with 0. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. Starting from 0, move 9 unit, 9. So move to the 9 unit, that is the number 9. 0 to 9. 9 minus 6. We have to subtract 6 from the number 9. From 9 to 8, 1 unit. So we have to subtract 6 units from the number 9. So 9 to 8, 1 unit. Then 8 to 7, another 1 unit, that is 2 unit. 7 to 6, 3 unit. Then this is 4 unit, 5 unit, 6 unit. Now the number is 3. So 9 minus 6 is 3. And this is the representation of subtraction of whole numbers 9 minus 6, which is 3, on the number line. Now we will solve question number 1. Find this multiplication of whole numbers on number lines. First we draw the number line. First bit is 2 multiplied by 6. First draw the number line. This is 0. 2 multiplied by 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 2 multiplied by 6. 0 to 2. Starting from 0, move 2 units. from 0, that is 0 to 2, 2 units. Then 2 multiplied by 6, we have to multiply 2 6 times. So 0 to 2, then 2 to 4, 2 units, 4 to 2, 6, 4 to 6, 2 units, 6 to 8, 2 units, 8 to 10, 2 units, and 10 to 12, 2 units. Now the number is 12. So 2 multiplied by 6 is 12. And 12, this is the representation of multiplication of whole numbers. 2 multiplied by 6, which is 12, on the number line. Now question number second bit B. 3 multiplied by 3. Represent the multiplication of the whole number 3 multiplied by 3 on the number line. First draw the number line. 0, 3 multiplied by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3. Starting from 0, move to 3 units, that is 3. Then from 3, move 3 units, that is 6. And from 6, move 3 units, that is 6, 3 units, 9. So 3 multiplied by 3, 9. So multiplication, this is the representation of whole number 3 multiplied by 3, which is 9 on the number line. Now question number third bit C. 4 multiplied by 2. Represent the multiplication of whole number 4 multiplied by 2 on the number line. First draw the number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number is 4. So starting from 0, move 4 units. Now it is 4. 4 multiplied by 2. We have to multiply 4 2 times. So from 4, move another 4, which is equal to 4 to 5, 5 to 6, 6 to 7, 7 to 8. Now it is 8. So the number is 8. So 4 multiplied by 2 is 8. And this is the representation of multiplication of whole numbers. That is 4 multiplied by 2, which is 8 on the number line. Now we will solve question number 1. Verify the associative property of the addition of whole numbers. First bit A. 7 plus 18 plus 13. We know 7 plus 13 is 20. We have to change this number 13 and 18. We have to interchange this number 18 and 13. That will be 13 plus 18. 18 plus 13 change to 13 plus 18, and this is the property. This is the commutative property of addition. Commutative. Now 7 plus 13 is 20, and 20 plus 18 is this is the associative properties. Now 13 plus 7 is 20, 20 plus 18 is 38, and 38 is the answer. So 7 plus 18 plus 13, we have to first rearrange this number, that is 18 and 13, change their places. That is 7 plus 13 plus 18, and 7 plus 13 is 20, 20 plus 18 is 38, and 38 is the answer. Now question number second bit B. 16 plus 12 plus 4. We know 16 and 4 is 20. We rearrange these numbers, that is we have to change these places, that is 12 and 4. 12 plus 4 will be 4 plus 12. 16 plus 4 plus 12. And this 4 plus 12, this is Now 16 plus 4, this is the associative property of addition of whole numbers. Now 16 plus 4 is 20, 20 plus 12 is 32, and 32 is the answer. So 16 plus 12 plus 4 is 32. Now we will solve question number 2. Verify the associative properties of multiplication of whole numbers. First we take 25 multiplied with 8358 multiplied with 4. We know 25 multiplied with 4 is 100. So we have to place this, we have to rearrange these places of this number, that is change these places of 8358 and 4. Now this will be 25 multiplied by 4 multiplied with 8358. 8358 multiplied with 4 is 4 multiplied with 8358, and this is commutative properties of multiplication of whole number. Now 25 multiplied with 4. First we multiply 25 with 4, then we have to multiply 8358. And this property is called associative properties of multiplication of whole number. Now 25 multiplied with 4 is 100. 100 multiplied with 8358, which is equal to 8358. There are 2 zeros, so we have to place 2 zeros. Now this is 8,35,800, and this is the answer. So 25 multiplied with 8358 multiplied with 4 is 8,35,800. Now question number second bit B. 625 multiplied with 3759 multiplied with 8. We have to verify the associative properties of multiplication of whole numbers. We know 625 multiplied with 8 is 5000. 625 multiplied with 8. 25 8 is 200. 8 6 is 48. 200 is 5000. Now we change these places of this number 3759 and 8. Now it becomes 8 multiplied with 3759, and this is the commutative properties of multiplication of whole number. 3759 multiplied with 8 is 8 multiplied with 3759. This is commutative properties of multiplication of whole number. Now we multiply first 625 with 8, then we multiply 3759. And 625 multiplied with 8 is 5000 multiplied with 3759. 3759 multiplied with 5 is 5 9 ja 45, 4 5 5 ja 25 plus 4 is 29, and then 5 7 ja 35 plus 2 is 37, 3 5 3 ja 15, 15 plus 3 is 18. Now it becomes 18,795, and there are 3 zeros, so we have to place 3 zeros. Now it is 1,87,95,000, and this is the answer. So 625 multiplied with 3,759 multiplied with 8 is 1,87,95,000, and this is the answer. Now question number 3. Is 16 multiplied with 16 divided with 4 division with 2 is equal to 16 division of 4 division of 2. Is this correct or not? Is there an associative property for division? We have to verify this property, associative properties of division is true or false. First we find out left hand side, that is 16 division of 4 division of 2, and 16 division of 4 is 4, division of 2 is 2. So left hand side is 16 division of 4, division of 2 is 2. Now right hand side, 16 division of 4, division of 2, and 16 division of 4 division of 2 is 2. Now 16 divided by 2 is 8. 2 is not equal to 8. So left hand side is not equal to right hand side. So associative property for division is not true in whole numbers. Is there an associative property for division? No, there is no associative property for division of whole numbers. Now question number 3 is 28 division of 14 divided by 2 is equal to 8. 28 divided by 14 divided by 2. Is there an associative property for division? We have to verify associative property for division of whole number. This is true or false. First find out the left hand side, that is 28 division of 14 division of 2, and 28 divided by 14 is 2, and 2 divided by 2 is 1, and right hand side is 28 division of 14 divided by 2, and 14 divided by 2 is 7. Now 28 division of 7 is 4, and 1 not equal to 4, so left hand side is not equal to right hand side. So associative property for division is not true for whole numbers. So is there an associative property for division? No, there is no associative property for division of whole numbers. Now what are the key takeaway of this topic? Associative properties of whole numbers. Associative properties of addition of whole numbers is, if three numbers A, B and C are given, then associative properties of addition of whole numbers is, first we add second and third numbers B and C, B plus C, then we have to add with the first number A, which is equal to, first we add first and second number, then we have to add the third number with the result of that addition of first and second number, which is the both are same. So it is associative properties of addition of whole number is true. Now associative properties of multiplication of whole number. If three numbers A, B and C are given, then first we multiply B and C, then we have to multiply with the first number A, which is equal to, first we multiply the first number and second number, then we have to multiply with the third number, and then this is true. So associative properties of multiplication of whole numbers is true. Now associative properties of division of whole numbers. If three numbers A, B and C are given, first we divide B and C, then we have to divide the result with the first number A. Then first we divide A and B, then the result of that number division with C, which is not equal. The left hand side is not equal to right hand side, and so associative properties of division of whole number is not true. So associative properties of addition of whole number and associative properties of multiplication of whole numbers is true, but associative properties of division of whole numbers is not true. There is no division associative properties for division of whole numbers. Now we will solve question number 1. Find 15 multiplied with 68 using distributive properties of whole numbers. 15 multiplied with 68. What is distributive properties of whole number? If we multiply A with B and C, that is B plus C. First we add B and C, then we have to multiply with the number with A. That is equal to, first we multiply A, multiply with B, then multiply A with C, then we have to add these two results of this number, that is First we add this number, first and second and third number B and C, then we have to multiply with the first number A, which is equal to, we multiply first and second number, then we multiply first and third number, then we add this both multiplication of these numbers. We can write 68 as 70 minus 2. Now 15 multiplied with 70 minus 2 is 15 multiplied with, we apply the distributive properties of subtraction of whole number, that is 15 multiplied with 70 minus 15 multiplied with 2. That is A multiplied with B minus C is equal to A multiplied by B minus A multiplied with C. We apply this distributive properties of whole number for subtraction. That is 15 multiplied with 70 minus 15 multiplied with 2. 15 multiplied by 70 is 15 7 ja 105. So 1050 minus 15 2 ja 30. Now 1050 minus 30 is 1020. Now 1020 is the answer. So 15 multiplied with 68 is equal to 1020. Now question number 2. Find 17 multiplied with 23 using distributive properties of whole numbers. We can write 23 as 20 plus 3. 17 multiplied with 20 plus 3. Now we apply the distributive properties of multiplication of whole number over addition. Now 17 multiplied with 20 plus 17 multiplied with 3. That is A multiplied with B plus C, which is equal to A multiplied with B plus A multiplied with C. This is distributive properties of multiplication of whole number over addition. Now 17 multiplied with 20 is, 17 multiplied by 2 is 34. Now it is 340 plus 17 3 is 51. Now 340 plus 51 is 391. Now 17 multiplied with 23 is 391, and this is the answer. Now the question number 3. Find 69 multiplied with 78 plus 22 multiplied with 69 using distributive property of whole numbers. We have to apply distributive property of multiplication over addition in these questions. 69 multiplied with 78 plus 22 multiplied with 69. Here 69 is common value, so we have to multiply 69, take the common number 69, then multiply with 78 plus this plus addition, then we have to add with 22. And this is the distributive property of multiplication over addition. This is multiplication and this is addition. So this is distributive property of multiplication over addition. Multiplication over addition. Now we add 78 and 22. 78 and 22, the value is 78 plus 22 is 78 plus 2 is 80. 80 plus 20 is 100. So it is 100. Now 69 multiplied with 100 is 6900, and this is the answer. So 69 multiplied with 78 plus 22 multiplied with 69 is 6900, and this is the distributive property of multiplication of whole numbers over addition. Now what we take away from these topics? Distributive property of multiplication over addition. What is the distributive property of multiplication over addition? That is, if we multiply the number, first number, then we have to add for second number and third number first, then we have to multiply with the first number. That is equal to, we multiply the first number A with the second number b, then we multiply the first number with the third number, then we have to add both the result of first number with second number and first number with third number. That is a multiplied with b plus c is a multiplied by b plus a multiplied with c. And what is the distributive properties of multiplication of over subtraction? If we subtract, if we multiply the first number with the subtraction of second and third number, then first we have to subtract second and third number, subtract third number from the second number, then we have to multiply the result with the first number. That is equal to, first we multiply the first number and second number, and we multiply first number with say third number, then we have to subtract the first and third number, the result of the first and third number with the multiplication of second and first number. That is a multiplied with b minus c is equal to a multiplied with b minus a multiplied with c. So distributive properties of multiplication over addition is a multiplied with b plus c is equal to a multiplied with b plus a multiplied with c, and distributive properties of multiplication over subtraction is a multiplied with b minus c is a multiplied with b minus a multiplied with c. This is the takeaway from this unit, distributive properties of multiplication over addition and subtraction of whole numbers. If you have not subscribed my YouTube channel, then please subscribe my YouTube channel. And if you have any doubt, then please write in comment section and I will reply. Keep learning, keep watching, and please subscribe my YouTube channel. Thank you.